Here we are at the Github Repository of Nuvolaris, our open source project. So for those of you who maybe have not yet contributed to it, I will just briefly go through the structure of the directory and explain you where are things and what are we going to do exactly today. So Nuvolaris main repository is this one. It's called Nuvolaris. And inside, you can see that we are using submodules. So because there is a .git modules file, you have all of these subdirectories which actually make Nuvolaris platform included as the submodules of Nuvolaris. Here in this main repository, you will find here issues. And this is where we actually do the work and list all the issues that we are working on right now or we think to work on in the near future. So if you want to contribute, it's like here that you want to go and look if there is something that you could actually contribute to. And in the meeting just after this one, we will go through the issues, and then if you're interested, you can maybe already see if you can help us with some of them. What will be the topic of today's training is Nuvolaris CLI GitHub repo, which is the command line interface for Nuvolaris written in Go. And I will explain you a little bit about the structure of this directory. And while I'm doing this, I will try to give you an overview of Go as much as I can do in 1 hour. But yeah, hopefully this should be enough to get you started. Like if you haven't worked with Go before, you should have at least have an idea of what is where and where to start. So before I go on, I would like to stress two things. If you want to contribute, the first thing that you should do is sign Apache individual contributor license. This is because Nuvolaris is released under Apache license, so whoever is contributed to it has to accept this license. So you send it to Apache and then they send you back the confirmation, and then you send it to us. Another thing that you should know is that the actual development, we are using forking Git flow. We are not using feature branching flow, which you might have been used to maybe in your work that you do every day. So basically that means that inside the repo we have, so this is mine fork. Inside the repo we have just one single branch, which is called main. So if you want to contribute, the first thing you should do is actually to fork this repo. And if we go here, we will see that we have already 12 people who forked the repo. So if you want to do it and follow the exercises, you should click this button like in the upper right and fork it to your own private GitHub repo. I won't do this because as you can see, I already did this. So, but if you want to, like the first thing you should do is do exactly this. So go into Nuvolaris CLI repo and then fork it to your private GitHub. So I'll just wait for a little while to see if anybody is actually going to do this. So anyway, once you did this, like let's say that you forked it into your own repo, the fork is not just a simple copy of the original repo. It's actually aligned with the original repo. So you can see here that my fork is actually a little bit late respect to the original repo. So I can just update it here. Like I can fetch and merge changes that happened on the main branch of Nuvolaris CLI original repo, and now I'm all up to date. Of course, you can do it if you already have forked. You can do it from your own fork, but I'm just showing you maybe the easiest way to do it. So I am just going to pretend now that this is the first time I actually forked Nuvolaris CLI folder. And what I have to do next is actually to clone my own fork. To do that, I will create a directory, which I will call Nuvolaris fork. You can actually call it whatever you like, but I keep separate directories, one with the original Nuvolaris and the other one with the fork, because here I'm doing the development, and then in the other one I'm checking pull requests and stuff contributed by other people. So it's just like my convention. Then I move into this directory, and then I would clone my fork by copying here the link. So I'm using the Git protocol because I have SSH keys set up for my GitHub account, but you can use HTTPS if you don't have them in any other way. I mean, you can just clone it. And the important thing here is to add recurse submodules. Why? Because if you go and take a look at Nuvolaris CLI folder, you can see that it also uses submodules defined in this file. So that means that actually we are pulling the code of OpenWhisk CLI, the task tool, and the kind, which is Kubernetes in Docker cluster, inside this repo. So if you want to check out both the Nuvolaris CLI and all submodules that it contains, you just have to put -- recurse - submodule, and then it will check out the complete code of the repository. If for some reason you forget to add recurse submodule, then you can do it later with git submodule init and git submodule update. I mean, it's not the end of the world, but better to do it right away. So now I have my local copy of my fork of Nuvolaris CLI. So I want to contribute to it. So what would I do? I would actually go to the main directory of Nuvolaris and check to see if there is some issue related to CLI that I could work on. But for the sake of this exercise, I will just invent one. So you can also create issues, and we welcome you to create issues. This doesn't have to be, for example, new feature. It can be just some bug that you report or any other thing that you think is important. So, but it is important that you create issue before you actually start working and coding or contributing anything, because even though this is open source, it's not a democracy. So we have to agree and align on the issues so that we avoid you doing things that maybe are not important or we think that shouldn't be done or for any other reason. So the good practice is that you create the issue, then discuss issue with us. And then when we are all aligned, you just proceed with coding it. So for the sake of this exercise, I will just invent an issue for myself, and I will say I want to implement nuv hello command in CLI. So implement nuv hello command that should print out hello name, welcome to Nuvolaris. So like this is an argument. So I will type in nuv hello Irina, and it should print out hello Irina, welcome to Nuvolaris. So I will just submit this new issue, and I will assign it to myself. This is also important because when you look at the issues, you will see that. Let me just briefly note down. So this is issue number 73. I will just note it down. If you go to issues, you will see that some of them are already assigned to some people and some of them still not. So if it's assigned, that means somebody already started working on it. So either you should sync or choose something else. So now I have my issue to work on. What will I do next is, if you go here and check the branches, I have to move to Nuvolaris CLI. You will see, of course, that it has only a single branch because that's the fork of the main branch. So I will just create a branch now and check out to it. So git checkout -b creates the branch and checks it out. So it's a good practice to call a branch after the issue you are resolving. So I will just call it issue number 73, implement nuv hello. Okay, so if I now check the branches, you will see that I am on this branch and I am ready to start working. And now what you should do is just type code dot. That means we are opening the VS Code editor inside the Nuvolaris CLI folder, this. And here the magic happens. Let me just show you. So these are the two messages that are important: reopen in container and open workspace. What happens here is that for development purposes, we have a Docker container, and you can tell VS Code that you want actually to develop in container by creating this .dev container folder. Inside, you have a JSON file, which actually specify that when you open the VS Code, it should run inside, like the development environment inside this Docker image that should be pulled. And this is really, really awesome because in this development image, you have all tools you might need to contribute to Nuvolaris. That means you have already Go installed, Python, Kubernetes in Docker cluster, everything that you might need. So you don't have to waste time spending like time installing tools on your machine. You just have to run VS Code inside the container, and that's all. So if for some reason you lost this message, you can open it from here and just say reopen in container. So now it will pull the Docker development image. It's going to be fast because I already did that. But once it started, you will see that, just disregard these messages, you have everything you need to run in container. And you should also open workspace by clicking this button. What it does is actually puts you inside the nuv directory. If you go back and if we look at Nuvolaris CLI repo, you will see that it has a nuv folder. And inside, there is actually Go code, Go source code that you should be working on. So this is really boring. Anyway, so we are set. You see the Docker container runs and opens the terminal, which checks that all tools are installed and are in the right place. So you have everything you might ever need. So I won't now spend time explaining you how to set up Go on your machine because that's already done for you. So you don't have to worry about it. And with this, we are ready to go. So let's see a little bit how Go code looks like, how the application is organized, and how you should actually start working with Go. So the first thing you should know is that Go is a compiled language. It's not interpreted. It doesn't run on any kind of virtual machine like Java or similar languages. It's actually compiled into a binary code that runs on the machine for which it's compiled. And Go comes with a tool which is called Go, which has a lot of functionalities already embedded into it. So you can use it to build code, to run tests, to to lint it as a dependency manager and all kinds of stuff. So if you just type, I don't know if you see it, maybe I can move this, no, somewhere, yeah. If you just type go build, it will build all Go files that you see here in the Nuv folder, and it should create somewhere an executable file which is called Nuv, you see. And then if you just run something like Nuv, you will see this is our command line tool, and these are the commands that are currently supported. So here we are going to add an additional command. I'm wondering, yeah, the Docker image remembered because I already did it, but never mind, we'll do it again. The commands that are already supported, but we are actually not using Go commands directly, but we are using something called task. And we have this, which is called task file, which if you're coming from a C background, might remind you of a make file. And it actually lists the tasks that you should be able to do. So basically, the default task here is to do the Go build. So if you just run task, it will pretty much do the same thing that we did with Go build. And then you can do Go test, which will run all the test files in this folder. But you can also do task test. So as the code is developing, we will be adding more and more tasks to this file. So basically, this is how you should use it. As you can see, Go source files have extension .go. And ideally, every Go file should have an associated test.go file, which contains unit tests for the associated file. Yes, in ideal world, as you can see, this is not the case, but we are going there. So as far as the organization of the project is concerned, Go doesn't impose any strict rules. So you can basically organize your project the way you see fit. I will talk a little bit later about the modules and the packages, which are an important concept in Go. But for now, let's like in this case, everything that you do in Go, like for CLI, is currently under this Nuvolaris folder. Now, how do you distribute applications written in Go? There is no central repository as you might be used to if you're coming from JavaScript world where you have NPM, or from Java where you have Maven Central. So basically, Go doesn't have anything similar. And the code is actually just shared via GitHub or any other source repositories. So basically, when you want to include a third-party dependency, what you do is you just reference the GitHub repo of this dependency. So if we just go here, you will see we are using Kong, which is the CLI parser for Go. And just by referencing its GitHub repo, we are actually pulling it in as a third-party reference. And if it's like a decent Go code, it would usually have a link to the reference, where you can see a description of all the functions and all the stuff you can do with this tool. So basically, Go does have a pretty decent standard library. So you can see it like when you are importing the package from Standard library, it looks like this. When you are importing the third-party library, then you reference the GitHub repo. So what makes this bunch of Go files an application? So going back to GitHub repo, let's take the Kong as an example. So usually inside the repo, you have a single module. And then inside the module, you can have multiple packages. That serves like to better organize the module. And the concept of packages is pretty much similar to what you have in Java if somebody has Java background. So basically, you create a subfolder with a name, and then all files, all Go files that you put into this directory should have package name that corresponds to the name of the directory. I mean, this is not imposed, but it creates a lot of confusion if you don't do this. And then inside the repository, you usually have this file, this special file, which is called go.mod. And this is somewhat similar to package.json if you're coming from JavaScript world. So there is a keyword module that references the name of the module itself. And then inside require, you have a list of third-party dependencies used by this module and the appropriate versions. So when you see this / indirect, it means that this particular item was not direct dependency, but was pulled by some other dependency, either because it doesn't have a good Go mode file or uses a different version. But you shouldn't worry about this because this file is maintained for you by Go. And then just to finish with this, you have the minimum version of Go to run this app. Going back to our example, we have a mod file with the name nuv. We have the minimum Go version. Then we have, oh, this is really giving me a hard time. Then we have replace keyword, which actually says that we are not pulling OpenWhisk CLI and task from their respective GitHub repos, but instead we are pulling them, as I mentioned, as local dependencies from Git submodules. And then we have the list of direct and indirect dependencies for this our CLI app. This file is actually updated automatically. So if you, for example, add a new dependency here, and then use any of the Go tools that actually compile the code, such as Go build, Go test, Go list, Go mod, whatever, it's automatically updated and the dependency is added to Go mod file. And then along with it, you have the Go sum file, which in ideal case has two items related to each dependency. One is like the reference to the repo with the version and the hash. And another one is the same thing, but the hash of the Go sum file itself. But that shouldn't worry you. So you shouldn't actually ever manually change anything in Go sum. And pretty much Go mode is maintaining itself when you add the dependencies. And is this clear? Let me know. Am I going too fast or too slow or any comments? No. Okay. So
okay, don't worry. I follow you easily. Go ahead.
Okay. So now let's go back and check a little bit the syntax of Go language. You might have heard probably if you have heard anything about Go before, that it has a really streamlined syntax, and that's true. So it's kind of a mixed language. It doesn't have objects, so it's not object oriented. So it doesn't have inheritance, for example. Then it doesn't have function overloading. It doesn't have pattern matching. It doesn't have named parameters, doesn't have exceptions, but to horror of many, it does have pointers. But the pointers, like the approach to pointers is pretty much simplified respect to C and C++, because there is no pointer arithmetic, there is no memory allocation and deallocation, and there is garbage collector. And then in most of the cases, Go is actually dereferencing the pointer for you, so you don't have to worry about this. So basically, I'll explain you just a little bit later when you should actually use pointers and how are they meant to be used in Go. But just one thing that I forgot. So about distributing programs. So Go has a pretty useful tool, which is called Go install. So if you just want to compile and install some Go tool on your machine, it's just enough to say Go install, then the reference to GitHub repo at version, and it will download and compile the tool for you. So let's, I will just show you briefly an example before I go in, just to find where I put the link. So let's install a simple tool which serves for load testing HTTP servers. So you can just type in github.com/rackle/hey at latest version. And here it is installed. And then you can just try out hey HTTPS Golang org. So it should actually send requests to Golang and check. Now it doesn't work perfectly, but you can see like it's measuring the average number of requests per second and time. So this is actually the idea. So you can install Go tools directly on your machine because they are compiled for the machine that you are actually executing them on. Anyway, so go back to to the syntax. Let's explore it a little bit. So as you can see, every file in this directory has Apache license header. That is required because this is an open source project, but I'll show you later like an easy way how can you generate the headers even if you don't have to copy paste the manually. There is an easier way. So the file has to belong to the package. In this case, this is a special package. It's called main. So all Go files in this folder belong to package main. This one, as we already seen, imports the third-party dependency to a Kong, which is CLI parser. Then here we see the definition of a variable. It uses the keyword var. Then it has the name of the variable. Then it has the type. I forgot to say Go is a strongly typed language. So every variable, everything needs to have the type. And then we have the initial value of the variable. Now, inside the same package, everything is accessible. So you can access this variable or this structure or this function. This is a special function, but in general case, you can just access it if if they are in the same package, it's accessible from everywhere. So you can access this structure from another file here because they belong to the same package main. But if you wanted to expose a variable or any identifier to some other package, then the convention in Go is to capitalize variables or functions. So this is really not idiomatic Go way of defining a variable because it's all uppercase, but this actually means because it's capitalized, it could be accessed also from another package if we had one, which is not our case, but this is the intent. So this is one way of declaring variables, and the keyword var works everywhere, either inside of the function or outside of the function. Then we have something which is called structure. And if you are coming from C, this might look very familiar to you. So it's a user-defined type. It starts with the keyword type. Then we have the name. Then we have the keyword structure. Then we have braces. And inside of a structure, you can really put everything. You can put either like variables of simple type like strings or integers or floats. You can put another structure, which is the case here. So this deploy command is itself a structure, and you can also put functions inside. I'll go back to explaining like what this is actually when we come to writing code. And then this is a special function, also looks very familiar to those coming from C and Java. It's called main. So this is where actually the execution of the Go program starts. It's called main, has the keyword function, doesn't have any arguments, and doesn't have any return value. So it's not even void, as you might expect. It's just nothing. So it doesn't even have a return. And this is a special function, as we said, function main. Go is pretty picky when it comes to syntax. So in order to stop like wars between developers around where should the brace be and should we use spaces or tabs, it actually gives you just one way. So this is error, as you can see. So the brace has to be in the same line. So there is nothing much to think about this. You have to write it this way. So it's really like opinionated. So the syntax is this. So let's see at another example of a function. Here we are also importing the third-party dependency, and function is also a type, but Go is not a functional language. But anyway, you can define a function as a type, and here we see the function defined as a variable. So just to avoid confusing you, I will write it like in the usual way, let's say. So how is all code in Go is like executed in functions actually. So we have the keyword function, we have the name, you see it's capitalized. So this means that this function is meant to be used outside of this package. And when this is the case, it's usually a good practice to put a comment like this before the function, because then you can easily generate documentation with Go doc. This function doesn't have arguments, but it returns two values. So in Go, function can return multiple values. In this case, it returns a string, which is actually the home directory of the user. And it returns an error, which is an interface, but I don't know if I will have time to talk about this anyway, just accept that it returns an error. And when a function is returning an error, it is a common practice to put error as the last returning value. So you won't actually ever write error, comma, string. You will always put it like this. So error is always the last value. Here we see Another example of how you can define and initialize variables. This way, like with column equals, works only inside of the function. And in this case, the type of home dir and error variables is actually inferred from the return value of this function. You see, this function returns also string and error, and then we assign return values of the dir function from this package. Actually, it's not the package, it's the name of the directory, but inside of the repository, you actually access functions by the name of the package. So if we went there and looked, we would see that inside we have the package called homedir. And then we call this function, and it returns us two values. The first one is string, the other one is error. And since there is no error handling at all, you have to think about what you will do with the errors returned by the function. In this case, we do nothing. We just propagate the error like to the caller. Notice one other thing. We have if, and then we don't have parentheses. Like the condition after if is just written like this. So in this case, if the function returned an error, we return an empty value as the home directory, and we return the error. Otherwise, if everything went well, we return the value of the home dir and nothing as an error. Okay, so maybe just to go a little bit and explain you about structures and the special type of functions you can have with structures. Let me just find a good example like this. So you see here we have a structure, something that we've already seen. In this case, it contains like simple values, booleans and strings and error. And then we have this special type of function, which is actually called a method of a structure. Why? Because if you take a closer look, it has this, which wasn't the case in the homedir function. So keyword, name, arguments, no return values. This one has something additional. And if that looks like a pointer to the structure, that's because it is a pointer to the structure. So it's really much like C syntax. So this means that this function step can only be called on the structure pre-flight checks pipeline. In this case, actually pointer to the structure of pre-flight checks pipeline. And why do we do this? Because this is not actually easy to explain. You could actually have a method on a structure that accepts just the structure itself. It doesn't have to be the pointer. But when you create a method which is actually like pointer, then you expect then that this method would actually change the calling structure, because Go is call by value, which means that whenever you call a function, the real arguments are copied into the arguments of the function, and then whatever goes on inside of the function, it doesn't really affect the real arguments. If you want to change this, so you want that the function actually does something on the thing that it was called with, then you use pointers in Go. And if you're coming from C, you will see that here, actually, it's dereferencing the pointer for you. So you don't have to do it yourself. It's automatically done. And then you see here, when we call this function, we are actually changing the callee, because we are like here, we are creating, initializing the structure. And then we are calling step function, which is a method on this structure. You see, it accepts like it's defined for this structure. And then like this function, extract Docker info, actually changes the structure itself. This is why we are passing it as pointer instead of just a value. And this is actually the use case of pointers in Go. Whenever you want to have some side effects on the thing that called the function, you would use pointers. Otherwise, you just use normal values without pointers. But this is not easy to explain, and I don't have much time. So I would like now just go and try to build our example, like our issue, if you still remember what that was. So we want to implement new hello. That should print out hello name, welcome to Nuvolaris. So let's do it. So we should start from the main function. I would here, so this is a structure dictated by Kong. And this is a tagged structure. It has tags here, which are actually simple key value pairs, but to be useful, there should be a code that knows how to interpret these tags. And this is what Kong does. It's a little bit like annotations in Java, if you've ever worked with this. So all of this have a meaning inside Kong. So we just annotate the structure, and then Kong knows how to deal with it. So I'll just do Control-C, Control-V here, and I will define my command. This is the name of the command, hello. I will call, this will be a structure called hello command. I don't need this. I won't explain you in detail now, but I will just call it Nuvolaris hello. And now I have to create this structure. To do that, I would just create a new file called hello go. I will not put header on purpose to let you know, to see what will happen if you forget to do it. So we said the function, the Go file has to belong to the package. So it's package main. I will create a structure. We said it starts with type. It's called hello command. It's structure. And inside, remember, this command has one argument, which is name. So I'll just define it as string. And then since I'm lazy, I'm just going to copy it from somewhere. Let me just find it. No, it should be in main also. To not look for backticks. So it is an argument. It has a name, let's say first name. And help, let's say hello. Something like this. And then this is something that Kong dictates, so I can't explain you now like in very much detail. I'll just implement the method that it's required to parse and run the command by Kong, which is called run. So it's again a function that accepts a pointer to, or let me find again, I will copy it from somewhere. Where did I have the pointer? Here. I'm having a hard time with this keyboard, so it's going to be pointer to hello command structure. And it has to be called run, doesn't have arguments, and returns an error. So what we said, this command is really simple. It should just print out something on the screen. So for this, you use format print line command, which is similar to console log or system out print line, whatever. So I'll just print out here, hello, and then I will call this h dot name, because this is like the structure that has a member name. Something like this. Where is my no. Never mind. Welcome to Nuvolaris. And you can see a pattern here, like this print line actually has two return values. So the first one is integer, the second one is error, but I'm just calling it and I'm not assigning return values of the print line to something. You can also do that, but it's not really a good practice. But for format print line, we have to, it's like a common way to do it. So since this function has to return error, I have to return something, but I'm pretty sure that I don't care about the error, so I'll just return nil for now. And this should be fine. Now I have to remember to save this file. One important thing also is that if you, for example, import the library, the package that is not used, like in this case, it will be a compile time error, because Go tries to minimize the size of your binary, like compiled binary file. But Visual Studio Code is smart enough so that when you save, it will actually remove it because it's not used. So, but anyway, like even if that wasn't the case, like Go compiler would complain. So at this point, it looks like it might work. So I'll just open, let me check if I saved everything, because I often forget to do this. I will just open the terminal, which I already have, and run task to see if everything builds. Looks okay. So let's try it out. Nuv hello. Oh, well, I have a space, but we can fix that. Again, task. Looks might work. So let's try. Huh? It expects only one argument, but that's fine. Okay. So now at this point, I might say, if I was inexperienced, that I'm ready to create a pull request. So what would I do is actually go, I like to do this from command line. You have all the tools you need inside the Visual Studio, but I just like to be, I like to do it from here. So it looks okay. So I changed the main Go and I added hello Go. So I can just add these two files and commit. I have a template for committing messages. that I usually use because I work from command line, but of course I could have just written -m and then the message. So in the subject line, I would just write implement nuv hello. If you want to put some other comments like more detailed description, I would put it here, and then I would also put Jira ticket or any other ticket if I had. Save this file, close it, and it's committed. And while we are here, I would suggest to read this article. I would just maybe paste it. I don't know if I have access to chat. Anyway, I can send you later. So this is a really good article on how to write Git commit messages. So I promise you, you will feel enlightened once you read it. So just go ahead and read it. Anyway, so I am now ready to commit. I will just push this, of course, that will not work because I haven't, I don't have the origin, but Git is smart enough to remind me. And here I am. So if I go to my fork, yeah, let's see. I should see this thing. And if you go to, we are for the continuous integration flow, we are using Git Actions. So when you commit your code, it runs, it builds the file, it runs the tests, and it checks if you have the license header in every file you commit. And eventually this will fail because I don't have the headers in the hello go file. So there is an easy way to fix it while we are waiting for this to fail. Because we have all the tools installed in the dev Docker dev image, you can just type license I header fix. And there should be one fixed file. So you see magically my hello file now has a header. So let's see if this, yes, this failed because it's failing on the license check. See, following files don't have, so always check this before you create the pull request. Now again, I have to repeat the process. Git commit, I'll just write fix header and push. And we can check like later that it will actually pass. Now, at this point, I would go create a pull request. Then I would expect somebody to take a look and expect some comments and whatever. But one comment that I would expect would be, this looks fine, but you don't have any tests. So it's time to write the unit tests. Now, I don't know, Michele, what we should do because I have only 2 minutes left. Maybe I should stop here and
probably yes, because
yeah,
we have to do,
because we are running out of time. So as a homework, write a test for hello command. You have a couple of examples. So you should do actually tests that run the command and then just check if it prints what it should print. So it's called example testing. You have a couple of examples here. I think it's in maybe Docker test. Yeah. So you should call your test example. And then like you should just call the command, print out the result, and then this is important. The first line has to be output comma, a column, and then just print out what you expect to be printed out and check with running task test or go test that it should actually work. So I would have done it now, but I'm running out of time. So I hope that this has been useful for you and that it gave you like a ground. Of course, this is just scratching the surface of Go. So, but hopefully you have some idea of where to start and what to expect if you want to contribute to CLI project. So I thank you all for your attention, and if you have any questions, we have 1 minute left. Yeah, so I'm here.